The first significant step in liberating mankind from superstitious distress at the incredible and dazzling phenomenon of the lightning stroke was made by Benjamin Franklin with his famous kite. During this experiment, Benjamin Franklin drew some of the lightning from the clouds and stored it in a Leyden jar just as one did static electricity. While writing the theories of relativity, the phenomena of lightning inspired one of Einstein's revolutionary thought experiments. Einstein imagined a stationary observer who witnessed two lightning bolts simultaneously striking both ends of a moving train. He concluded that an observer standing on the train would measure the bolts to strike at different times. Despite having a clever and crafty understanding of the phenomena, it wasn't until 3 decades after relativity that researchers began to probe into the mysteries lightning. What causes lightning? The moment precipitation starts in the thundercloud is when the significant downdraft begins and is the moment when the electrical phenomena arise. We have what is called a mature thunderstorm. There is a very rapid updraft which, in this stage, goes up to about 10,000 to 15,000 meters, sometimes even much higher. The thunderheads, with their condensation, climb way up out of the general cloud bank, carried by an updraft that is usually about 60 miles an hour. As the water vapor is carried up and condenses, it forms tiny drops rapidly cooled to temperatures below 0 degrees. There are rapid and irregular gusts of air generating enormous turbulence in the cloud. Experiments of various kinds, including bravely flying airplanes through thunderstorms, tell us that the charge distribution in a thunderstorm cell is as shown. We can see that the charge on the ground beneath the charged regions in the storm forms an opposite polarity. In this scenario, charges can jump from the cloud to the ground and from the ground to the cloud. It is strange to contemplate the existence of ground-to-cloud lightning. The notion that immense charge originates from something like a tall tree and is shooting into the sky seems foreign. However, it has been determined that almost all lightning that strikes a tall object is ground-to-cloud, meaning it originates from the earth. However, the strangeness of the phenomena does not end with ground-to-cloud occurrences. In recent years, major corporations and institutions dealing with aeronautics or space have invested heavily into studying lightning events. For them, understanding the phenomena is a matter of life and death. To ensure the safety of air and space travel, this potentially deadly phenomenon needed to be further understood. During the summer of 1934, lightning stroke recorders, using Lichtenberg figures, had been associated with 2 experimental television antennas of the National Broadcasting Company on top of the Empire State Building. The Empire State Building in New York City is a steel frame building surmounted by a tower whose top is 1250 feet above the street. The top of the tower is constructed of metal, and extending above the top is an antenna system of the National Broadcasting Company which was used for television experiments. The photograph shows the antenna structure placed atop the tower in July 1936. The antenna extends above the triangular system and terminates at a point 38 feet above the top of the building. Here was the perfect place to get oscillograms and photographs of the same stroke. The best method of approach to the problem of determining the mechanism of discharge would be to photograph with a boy's cameras the same stroke whose current time characteristics were being determined oscillographically. By knowing the speed of the film drum rotating and measuring the distance between the events captured on the film drum, we can calculate the exact period between events. Before the Empire State Building experiments, the notion that lightning strokes might be multiple existed for many years. During the summers of 1935, 1936, and 1937, Practically all the strokes to the Empire State Building after dark were photographed with different Boys cameras. Researchers definitively captured the multiple strokes in a single lightning strike from these experiments. Pictures of lightning events at the Empire State Building using a modified Boys camera clearly illustrate a series of events composing each strike. Situated in the center of the photograph, we can see the Empire State Building. This image, captured at the Empire State Building, depicts a single lightning event. Thanks to the rotating film apparatus within the Boys camera, we can see that within a single lightning event are multiple strokes. Initially we see a low-intensity long continuing discharge. After the initial discharge, there are a following 6 non-continuing discharges. The 7 combined discharge strokes construct the mechanics of a single lightning event. Of course, the 1930s did not mark the peak of our knowledge of lightning phenomena. Today, with modern variations of the Boys camera, we can not only separate the event into unique strokes, but we can also observe the processes that occur during each individual stroke. Here, in the phenomena of lightning, I believe we can finally pull back the veil on reality to glimpse into the mechanics of our universe. If the scalar field exists, why has its existence not been observed by researchers in laboratories? If we remember, field cycles mark the shortest time duration between instances of observed reality. No device constructed of matter can conduct 2 measurements during a single field cycle. Without 2 unique observations, we cannot analyze any changes during the process. While we consider this, we can see how conducting observations of the process of a field cycle is seemingly impossible. Not only are field cycles too short to measure, but we must also remember that cycles progress entirely internally to the 2 individual parties. For an external observer, such as laboratory equipment, there would be no measurable changes in a system of matter even though the 2 parties are continually undergoing field cycles. So why is lightning so unique? Why is lightning so different from any experiment conducted by man? What is it about this phenomenon that makes it so incredibly special? To understand this, let's first look at the hidden processes within each lightning event. From modern experimentation, we know that a lightning event is composed of 2 different types of strikes. The initial strike in a lightning event is called the step leader. Following the step leader is a series of return strokes. The lightning stroke is initiated by a so-called stepped leader beginning at the cloud and finding its way to the earth in steps. Stepped leaders develop within thunderstorm clouds when charge differences between the central region of negative charge in the middle of the thunderstorm, and the small area of positive charge near the storm's base becomes large. The leader's path from the cloud to the ground can be very jagged and indirect. Curiously, the progression of a step leader is not continuous. Using modern Boys cameras, we can see a chain of small individual processes that constructs the mechanics of a step leader. We can see that in a step leader, the charge forming what we call the tip of the strike appears to surge ahead in 50-meter segments, momentarily pausing after each jump. The step leader treads virgin space. It plots out a path for the flow of charges. Once the route is formed, multiple return strokes travel back and forth, allowing the opposed charges between the bottom of the cloud and the earth to equilibrate. Is this step leader allowing us a peek into the mechanics of our universe? Are these unexplainable mechanics fashioned by matter undergoing cycles within the scalar field? According to our scalar field model, the process observed during a step leader depicts charged particles progressing in time by undergoing cycles in the field. We can see that each 50-meter jump can be viewed as a cycle in the field. And the pauses between each jump mark the completion of each field cycle. It is at this instance that reality is observed. When reality is observed, we can once again observe the existence of the charged particles. So why lightning? Lightning is unlike any experiment that humans can conduct in a lab. During a lightning event, there is a colossal massing of charged particles. This massive number of charged particles are grouped during a step leader, and all undergo the same cycle. This scenario in the quantum realm creates processes that can be measured and observed without interacting with the quantum particles. As each charged particle progresses, They constantly emit photons of visible light. By observing emitted photons with the progression of time, we can observe the quantum mechanics that construct a lightning strike without interacting with the charges in the strike. We can see that both the magnitude of the massing of charges and its monumental structure construct a scenario unachievable in the laboratory. In one of the grandest phenomena of the natural world, it is here that the universe gets sloppy. Do the step leaders, occurring during each lightning event, expose the scaffolding of reality? I believe that the phenomena of lightning is our first and possibly only scenario in the natural world providing evidence of the scalar field at distances shorter than the Hubble radius. Hidden in the phenomena that helped inspire special relativity may be processes that contend the very existence of general relativity.